These are problems from homework from last night, and today is the 26th of March in 2013. So we're going to be going through these as a class and learning how to do the specific heat type problems. So, Vince, you are up first. Would you please look at the problem and tell us what are we supposed to find in problem number 4?
How much heat has been absorbed by us?
I'm sorry, I didn't understand.
Heat of maximum.
The heat will be in joules. So it's always nice to write down the unit of measure. And so I wrote it out there because joules is a new unit of measure for most of you. And let's go on now. And with joules, there's an important, well, with any find, there's an important corollary. And that is the find determines how we write specific heat when we're doing the grid method using fractions. So this all follows from what we've done in the past, but it will be a little bit unfamiliar to you until we actually get into it. And we'll talk about this more in just one moment. So let's go on. And Leslie, would you please tell us what are we going to have in the given?
34.4 grams.
Yes, 34.4 of ethanol. And what else are we going to have?
78.8 degrees Celsius.
78.8. Is that the, what is that? See, there's three kinds of temperature in these problems. There's the starting temperature, the ending temperature, and what I refer to as delta T. Okay, so the delta T, that's not what the delta T is. What is that? What is this temperature right here, Leslie? Starting, ending? You tell me.
Then,
It's the ending? Okay. And what's the starting temperature?
25.
25. Okay. So, you might remember when we were doing the gas laws, that if you were given degrees Celsius, what did you do right here in the given? Very good, you remember. Excellent. Okay, we added 273, and that gave us what kind of temperature? Oh, no, not Fahrenheit.
Kelvin.
Kelvin, yes, Kelvin, which is the only thing the gas laws are proportional. Okay, so when we subtract the beginning temperature from the ending temperature, that, right down here, is our delta T. And delta T is what we have in delta T is what we have in the specific heat. And we're going to use the chart in the back to get the specific heat of ethanol. Not in the back, but it's in page 492. And the specific heat of ethanol is what we're going to use in our calculation. Now, let's put your attention right back up here. To determine how specific heat is written, we need to know what the find is. And so the find was joules, and because it's joules, that means joules will be on top in writing this number right here as our first fraction. So James, would you tell us, how is that fraction going to look when we write it? 2.44 what? Joules over 1 what? Grams degrees Celsius. Very good. And that's our starting fraction for this problem. Now, James, if the find was degrees centigrade, how would that fraction be written? Degrees Celsius? Why would you say just degrees Celsius? What's on the bottom of the fraction right now? That's going to have to all be on top. grams degrees Celsius. And what is on the bottom? What's the number that goes with joules? 2.44 joules would be on the bottom. You see, you have to keep, these guys have to be kept together, as do these guys. Okay? So that's good. Good. You learned something, didn't you? Yeah. Excellent. Okay, Louisa, you're on. And I need to know for the next fraction is going to be the grams. So, would we have grams top or bottom in the next fraction? Top, and what would be on the bottom of the fraction? Is this a ratio or a given quantity? A given quantity. So, the bottom is going to be 1. Remember in a lot of our fractions we were writing a given quantity over 1. Okay, that's what we're going to do in this guy. So what would my fraction look like? My next fraction. Yes, 34.4 grams of ethanol over 1. All right? Folks, you need to write all of this. Okay, and what, Annabelle,
Yes.
you get to tell me what the next fraction is. This is what we're going to put with our fraction, and is that 53.8 degrees centigrade going to be top or bottom?
It's going to be on the top.
It's going to be on the top. Good. What's on the bottom of the fraction?
A 1.
Again, very well done. Okay, so that's our 3 fractions. That solves this problem, because that will give us joules. You'll notice that the degrees centigrade here will cancel the degrees centigrade down here, and the grams here will cancel the grams down here. Okay, and what we get at the end is 4.52 times 10 to the third, or we could write that as 4,520. Are you writing this down? Good. Yes? 10 to the third came from this number, because when we calculate all of this out, it will be 4,520. And all we did was put that in the scientific notation, which would be 4.52. We only have 3 sig figs in the question, or in the numbers here. I'm not going to do that, but you need to be able to recognize it both ways. So if you're having problems with scientific notation, you need to fix that before the CST. Yes?
So you always put the givens in the one? Like, when you're multiplying?
No. The reason that I did it in the order that I did it, why do we have this guy first? So we know whether this will be top or bottom. You see, if this guy's flipped, that means that grams and degrees centigrade will be on the top here, which means that grams and degrees centigrade would be flipped as well. But this problem is not that one. Okay? So, and you'll see that in another problem in just a moment. So that's a good question. Very good question. Okay, any further questions about this particular problem? Okay, if you have written this down, you will be far better off when you go to do your homework, because your homework is going to be more of these kinds of problems. You'll have 5 of those tonight. Okay? So let's go ahead and button this up, and we'll button up this guy here, and this, and we'll be ready for our next problem. Alright, here we go. Now, on this one, Ricardo, would you please tell us what the find is?
Specific heat of gold. I don't know how to say that.
What is the find?
Oh, what was the final temperature of gold? The initial temperature was 25 degrees Celsius.
Ah, the ending temperature. Okay. When we do our calculation, we are not going to get the ending temperature. Are we going to get beginning, ending or delta T when we run the calculation?
The ending temperature.
No, we're going to get delta T. Absolutely. That's what we're going to calculate. Then we take the delta T that we get and subtract that or add it. First we determine how the specific heat is written, and the fact that it's absorbed will tell us that, like if I put a match under your nose will absorb the heat and that will hurt. Right?
Yeah.
Okay, because it's absorbing that heat. Okay, so absorbing means that,
Adding.
did the temperature of your nose go up or down?
Goes.
You bet it went up. Yeah. Much to your consternation. Okay? So, are we good there? Yeah? Are you okay with that?
Yeah.
Okay, edit. You're going to tell us what the given is. .60 what? Okay, grams of what? It's gold in them there hills, yes. Okay, good. What else do we know? Okay, yes. We have 276 joules of heat. All right. And is that absorbed or given off? It's absorbed. That's what it says, isn't it? It says it's absorbed. Okay. And what's next? (25.0°C). And what else do we know? See, that's the starting temperature. So what else are we given? .129 what? Per degrees what? Celsius. Yes. There's 3 different temperature scales, so it's important to know that it's Celsius. Okay. Now, this guy in this problem, the starting temperature, is not used in the calculation. So the calculation is going to give us what? What do you think? Is it going to give us starting temperature, ending temperature, or delta T? This temperature edit right here is meant to be the delta T, like we had in the last problem. In the last problem, they gave us delta T. In this case, we're going to have to calculate delta T. And when we have the delta T, we can add it to this guy because the temperature is going to go up. It's increasing because the heat is absorbed. Okay? And so what we're going to do is we're going to calculate that delta T. Now, here's the deal. We're going to solve for delta T first, and then we're going to subtract or add. In this case, it's what? Add or subtract. Add. Yeah. Okay, good. So, now we're going to go ahead and do the calculation. Tony, you need to tell us what our first fraction is going to look like. What's going to be on the top and what's going to be on the bottom of our fraction. Here's our specific heat right here.
0.129 joules over grams degrees Celsius.
Okay, what is this stuff up here? Whoops. Get that back. And what does this stuff up here mean, Tony?
Oh, which one goes on top? Which one goes on
Uh-huh. So, what has to be on the top of our fraction?
Degrees Celsius.
Degrees Celsius. So, what is the fraction going to look like?
Degrees Celsius. Grams degrees Celsius over.
Good. Yes.
Why does it,
Why does it have to be grams per degree centigrade on top? Because we're looking for degrees centigrade, and if we don't have this degrees centigrade on the top, if it's on the bottom like it is right now, we'll have the inverse of the answer. Right? Okay? So we want to get the correct answer, we've got to flip it on this kind of problem. We would do the same thing if if the fine was going to be grams. Okay, it'd have to be on the top. Alright, so let's go ahead and look at that first fraction. See, there it is. Looks pretty weird, doesn't it? Very, very strange stuff. But this works. If you're not writing this down, you have a screw loose. Seriously, you need to write this down. Everything that's on the board. And there's a good reason for it. Because if you don't, you're going to get into tonight's homework and you won't understand how to do it. Because they all follow the pattern in these three questions. Okay, so let's go on, and Tony got us set up right. Now, purge. Tell us, where is this gold going to get used? The grams of gold. In the next fraction, will grams be top or bottom? Okay, look at where grams is in that first fraction. Ah, good, you saw it. Excellent, you saw it right away. That means you just weren't thinking the first time. Okay. Well, it's okay. We all have it. We all have it happen to us. All right, so yeah, the grams is going to be on the bottom now. And you see, if we didn't have this guy flipped, this guy would have to be on top, and everything would come out all ball-like stuff. Okay, we'd wind up with inverses. And purge, what are we going to do with, I don't know, let's let someone else do the next one. Enrique, yeah, would you please tell us, what are we going to do with this joules? Is that going to go top or bottom in the next fraction?
Bottom. I mean top. Top.
Yes, it's going to go on the top. Excellent. Why does it go on the top?
Because we have to cancel out the 0.129 joules, so we don't get that.
You betcha. This joules here is on the bottom. And so the joules here has to be on the top. Perfect. Excellent. Now when we run the numbers, let's just get this off over here, out of the way. When we run the numbers, this is what we come up with. Okay, and that number is not the final temperature. It's not the ending temperature. It's the delta T. So, Samantha, not with us anymore. Johnny, you're on. How are we going to figure out our ending temperature? We know what the temperature change is. We know what the starting temperature was. How are we going to get the ending temperature? Okay, let's think for a moment. Isn't this the change in temperature?
Yeah.
Okay. If that's the change in temperature, and this is the starting temperature, and what do we know about what's happening with the temperature? Yeah, there you go. Okay, so when we add those two together, that gives us our final answer. Are you all writing? Now you've got it. Have you been writing this down? How do you expect to do the problems tonight? Okay. Okay, for question 6. This is going to go for Yana. Okay, Yana, would you tell us, what are we supposed to find in this problem?
the substance? No.
Uh-huh, you're right.
Specific heat.
The specific heat, and from the specific heat, we've got to find the substance.
Yeah.
Okay? Now, Yana, we're going to do this together. I'm going to go to the table. We're turning to page... Oops. What page are we supposed to be on? 492. Okay, we're on page 492. Now, I'm going to give you some actual readings that might be gotten in an experiment. and you tell me what the substance is. So I'm looking at 0.451. And who's that likely to be?
Iron.
Yes, that's going to be iron. And if I had 2.50, who is that likely to be? Yes. Okay, you see, it won't always be exact. In fact, there's usually going to be a little bit of difference. So you have to see which one it's closest to, and that's the guy it's going to be on the chart. Okay, we had problems like that before, only we were dealing with different units of measure. Right? Okay. And as long as I'm thinking of it right now, let's take a 500 gram mass. I've got one in my hand right here. And that 500 gram mass, what I'm going to do is I'm going to put it into water at 25 degrees centigrade, but this will be at 95 degrees centigrade. Okay, so the water's at 25, this guy's at 95, and now the temperature's going to change, right? Temperature of the water's going to go up, isn't it? Because this is, it has more energy in it per unit than the water does. So the water temperature goes up, and it keeps going up until finally this guy and the water are at the same temperature. This is what specific heat is meant to calculate. Okay? And the way we would get the specific heat of water is to figure out, first of all, how many grams of water we had. We'd have a temperature change, wouldn't we? Okay? And let's say we wanted to find out how many joules of energy there was transferred to the water. Well, we'd be able to figure that out too, and with the specific heat of water, we could tell you that the joules of energy would be a certain amount. Because you have no way of calculating that with the equipment we have right now. But that's why we have specific heat, to be able to calculate that kind of thing. And maybe that will help you with this next problem. So, let's go ahead and get the given. And Alyssa, would you please tell us what the given is? Or givens?
155 grams.
Okay, 155 grams of unknown stuff.
25 degrees Celsius.
All right, carry on. Next one.
25 degrees Celsius.
Okay, 25. And it went up to 40. So that's our temperature change, isn't it? We would call that a delta T. Okay, so the delta T, okay, just like we did with the temperatures in the gas laws, we're going to calculate that right here as part of our given. Okay, and what else?
5,000
Absorbed. Good. Okay, so now we're pretty much ready to go, and my little word of wisdom up here in the top right is, still the find determines how specific heat is written, and specific heat will be written in the exact order that it is in any specific heat that you would see. So you are going to solve for specific heat, which has those units of measure. So that tells you where everything is going to go, doesn't it? And the absorbed, again, means increase. Both of those pieces of information are not critical to do this calculation, but they're good to know. So let's go to Hofstad, and would you tell us what's going to be on the top of our fraction? This is called plug and play. Okay, it's the easiest kind that we have. It's not three fractions. It's one fraction only. So what's going to be on the top of our fraction? Okay, let me give you a little hand here. Okay, right here we have our template. And what we're going to do is from our given, we are going to work the numbers right next to their corresponding units of measure. Okay, so what would the top of our fraction look like? And so what's the top of the fraction? Yes. Okay, it's good for the people watching the video to realize that this is not as easy as it seems. Okay? All right, so what's the bottom of our fraction going to be? 255 grams times, yes, times 15 degrees Celsius. There it is. See, this is the easiest time. And this is where specific heat actually came from. Somebody did the experiment. They found out that temperature went up a certain amount when we added a certain number of joules of heat, which we don't have the equipment to do here, but there's a way to do that. And then they looked at the temperature increase, the joules and the grams, and made this thing up and called it specific heat. Okay, that's how this came into being. Have you written this down? Have you written it all down? Okay, so now we go to the chart and we find that the ethanol is the substance. Because, we have to calculate first. Okay, and so we have the number here, and in the chart, ethanol is listed as 2.44, but 2.45 is very close, and so this would be the specific heat that we get for ethanol. Uh-huh. Yeah. Yep. That's how you determine the substance. And do you remember when we were doing the molar mass lab? Yeah, we'd figure out the molar mass, and whichever guy on the periodic chart had the closest mass was the substance. And most of you nailed almost all of them. Out of 12, most of you had anywhere from 10 to 12 of them absolutely right on. And that's good. So this is the model for how to do specific heat problems.